Hello and welcome to episode 115 of Linux Dev Time. I'm Joe.
I'm Omolith.
I'm Kevin.
And I'm Andy.
Good to talk to you all again. Recently we were talking about software that you'd like to rewrite, and Andy, you brought up SQLite.
Yeah, well, I was reading today that SQLite is installed, there's like 1 trillion SQLite databases in the world or something like that, and it's totally amazing and cool that this software is so useful to the world. But it's like intriguingly self-contained. Like SQLite is just a library that just works with a file on a disk and does something that on the face of it seems quite simple. So it's one of those things that I think would be really attractive to try and rewrite. Obviously harder than it initially sounds.
And I think some of the context around this as well, too, was that when we were talking about software to rewrite, it's not necessarily because it'd be any better, more or less. It's more because it would be an interesting thing to do or just a fun topic to dive into, right?
Yeah, just for fun, because it sounds interesting. It sounds like the kind of thing that you might get some insights into how things work if you dig into implementing it yourself. And
I guess also there could be some socio-political things around SQLite specifically as well that might benefit from a rewrite. Now, and I'm not saying like we're practically rewriting SQLite, but if we were to hypothetically jump into that world, there are other reasons that we could look at that particular project.
Yeah, SQLite is unusual in terms of its licensing. The core code is public domain, which in some jurisdictions doesn't exist, and in some jurisdictions is kind of equivalent to kind of do anything you like with it. But then the test code is proprietary. So they have what they claim is a vast amount of really comprehensive test code, but it's proprietary. That, for me, makes it a weird project because one of the freedoms you get with open source stuff normally is freedom to kind of research and understand the software. And to me, to be able to really understand it, you need the tests. And to be able to implement your own version, you definitely need the tests.
Yeah, if you can't test it, it doesn't exist to you.
Yeah, I mean, obviously, this is my testing-focused bias, yeah.
It's, I think, deeper than that as well, because SQLite is also held up as like the top project, probably open source wise, as a project that has amazing tests and is super well tested. Mm-hmm. It's absolutely rock solid. And yet, like when you dig into it, yes, the test suite, I'm not exactly sure how rock solid it is. I'm not implying that it's not. It could be absolutely rock solid. But my point is it's proprietary. It doesn't come with those same open source freedoms that we kind of traditionally think of, especially when we're talking about a project that is held up as kind of the pinnacle of open source.
Yeah, and it's also a closed development model, right? They don't take outside contributions. So it's really quite unusual.
I've heard different takes about the not taking outside contributions. Yeah, I think that's strange. And I mean, it's their project. They can do what they want with it. But I've heard some people say that, like, yeah, when you have a project like this, it's written in C, one way to control the quality of the code is by not accepting any outside contributions. And I'm sure that's a viable approach. But also, it's one that I don't necessarily agree with, because I think you can still accept outside contributions, and there's nothing saying you can't like mold those contributions. You can't work with the contributor to have the same quality and code standards. To me, it's a false dichotomy. Not taking outside contributions has nothing to do with the code quality of the end result.
Yeah, that does seem odd because you don't have to take every contribution that's offered, right?
Exactly.
It's weird for me because everything in me kind of cries out against this approach, but I also can't argue with the results. It's a very successful project because it works very well. And it's up to them how they run their project. But one of the things I really like about open source is that the thing is open in more senses than just you get the code.
Yeah, and I mean, you don't have to take every contribution that comes in, and you don't have to take them verbatim either.
Yeah.
You can always work with the contributor and be like, hey, this doesn't meet this particular standard or this benchmark. It's not one or the other. And maybe there's times where someone says, hey, here's my contribution. I'm not going to, conform to your project standards. That's fine. You can still base work off of that and like take ideas from it. It's a different model.
It does take investment of time. So if they took external contributions, they would spend time mentoring and reviewing and so on.
Which is a huge part of a lot of open source burnout too, is it's all that additional non-code stuff, all the issue triage and the working with the contributors. So it's not to say that it's necessarily wrong. Like, yeah, those things do take a ton of time, a ton of energy, and a ton of resources.
Yeah, and it's one of the things that I think is really cool about open source, right? That there's this community aspect to it. So missing out on that goes against my grain.
SQLite is incredibly popular in other open source projects. And I suppose the question I have is why, given the relatively unusual development model that they have?
Well, for one, I think it's a simple way to get a database. And that's simple, not necessarily easy, but it's easier than something like PostgreSQL or MySQL. But in addition to it being easy, I mean, it is great software. It is very well written. They have a great test suite, even if it's proprietary. So it is good software. I think because it's good software and it's so simple, it just always gets suggested as the initial thing, the go-to thing, because it's the easiest of that category. And then people don't necessarily know about the other practices. Like I myself have been guilty of not looking into the details of every single project that I've gone to build something on top of or incorporate. So I don't think people can necessarily be faulted for that, for not knowing, but it is an interesting aspect of that particular project.
The thing is that SQLite is really good for some types of problem, and it's a really elegant solution because it just works with a local file on your local disk, which for the first time I heard about that, I was like, yes, why did we not do this before? It's so simple. But then maybe now it gets used for any time you would otherwise just use a local file on your local disk that is some other form or something like that. Or even it gets used at times when you shouldn't be using a local file on your local disk just because everyone else uses it, maybe.
Well, I think of a project that switched to SQLite relatively recently, and that is Audacity.
Yeah.
So the older versions of Audacity, as you're recording, like we are right now, it splits the audio into chunks of about a megabyte and just saves a load of those little chunks of audio. And so then if I want to send you my session, as it were, my project, I have to send you the small project file, which basically is just a list of all those chunks of audio and what order they're in. And then I have to send you the folder that has all that audio in. Whereas the more modern versions of Audacity just have one project file and all the audio in a SQLite database, which makes it more portable. It means that I just have to attach one file to the email or whatever it is that I'm sending you.
Yeah, the single file thing's really good. I mean, it could be a zip file with all that other stuff in, right? But I've noticed a slowdown in things happening in Audacity since that change.
No, I have not noticed that because I'm using the old version on, I think, 2204, because I don't upgrade if I don't have to.
That's not necessarily because of SQLite, though. It is capable of serving like hundreds of thousands of requests per second. It could just be in their poor use of it.
Or it could be an example of a situation where SQLite isn't the best solution.
Could be too, yeah.
And there are edge cases around SQLite as well. I've run into issues personally with using SQLite on a ZFS file system where there's something around the way fsync works and how it writes the data to disk. There's something weird there where it can end up hanging. And actually, there's an open issue in ZFS where if you try and have a SQLite database on ZFS, there's some timeout that can end up happening. And it can even end up into the seconds. And when you have projects that rely heavily on it, or many projects that rely on SQLite, such as I want to say some stuff in Flatpak has to do with SQLite. So you can do an upgrade, and an upgrade can take minutes on a particular system, whereas a non-ZFS system could end up taking milliseconds. So like there's weird edge cases around there. So that to me says there's maybe something around the super well-tested claims. Like I'm not saying SQLite is not well tested. That is not at all what I'm trying to say. However, it's software. It's software just like any other software. There's going to be bugs. There's going to be CVEs. There's going to be stuff out there. So I think this is just one of those things that kind of points against that. Like, oh, it's perfect software that is the most tested out of all of them.
Another data point is that I a while ago ran into some performance problems with use of IndexedDB in web browsers, and I was testing in some detail how Firefox and Chrome responded to different, like, large IndexedDB databases. IndexedDB is like the ability to store stuff relevant to your web page on your local browser. And I'm pretty sure I remember that rightly, that Firefox's IndexedDB implementation is based on SQLite and Chrome's is based on LevelDB.
I do think so.
Good. I'm glad to hear that. I might have got that right. And Firefox in general scaled much better than Chrome. So in that case, it seemed like SQLite was better for that large use case than LevelDB.
There's a project out there that used a JSON file as its database, its internal database representation, just straight up raw JSON. And it turned out the performance was fine for a way larger database than you would think should be in just a single JSON file. It turned out like they didn't, they still got the same single file properties, didn't have all of the like SQL complexities, and could kind of just implement that stuff in very simple queries internal in their program. So like there's other places where if you like the single file is attractive to you, I think there are other ways, like you don't necessarily even need to scale to a SQL database. Now, I'm not suggesting this necessarily for like massive production scale, but I do think it's an interesting data point where like sometimes you don't even need that level of database.
Yeah, so actually I did that recently with my Santa Circles Secret Santa website. What that does is it stores a kind of key value type store in memory, and every few seconds it saves that out as a JSON file, and that's its entire database in quotes. And it's like super, super fast because it's all in memory, right? So long as you don't run out of memory, it's going to work fine.
Couldn't it just be a CSV?
Yeah, but it's basically effectively equivalent to a CSV, right? It's just JSON is a slightly more convenient format but yeah, the point is it's all held in memory, which is why, something like Redis, which is another example of a thing which is held up as being an awesome piece of software that everyone uses. The reason why that's fast, part of the reason why that's fast is because everything's in memory. So I just held everything in memory, and then I got that speed without any external service at all.
When I first started writing Willow, it didn't use any SQL database to begin with. It was just a CSV, and I used some CSV library, but I didn't even have to do that because the format is just comma-separated values. I could have done it with printf or whatever.
Yes.
And it would have been just as simple.
Now we're talking.
There's a few times that you lot have mentioned printf. You need to tell me more about this.
Oh, like about how if you are a real debugger like GDB or LLDB versus printf debugging, which is not real debugging. That's something I hear routinely, which is absolutely not true, by the way. Printf debugging is a real thing. I would say the majority of developers probably use printf debugging. And this is not to say also that GDB or something along those lines is not better. It probably is better. And in many cases, I would actually say it is better. We'll just go out and say it is better. However, it is a whole other topic to learn. And sometimes it's just easier to print a value, look at the console, and recompile.
Every time I reach for a debugger, I have to remind myself how to use that one.
Yeah, so just to be clear, Joe, in case you were asking what it is, printf debugging just means printing stuff out to the console while your program's running, as opposed to using some clever tool to monitor the variables and everything as the program runs.
What, and then just manually reading it?
Yeah, just looking at what it prints out and seeing whether it's what you expected.
Right.
It's kind of like log files ephemerally that you can just look at.
Yeah, modify the code so it prints some stuff out, try it out, see whether it prints what you thought it was going to print.
And then usually there's some cycle in there about, ship the code, realize that you left a printf statement in there, ship out a hotfix to remove that printf. Those are in there too.
Fill the disk of your customer, take down the data center. Yeah, I think printf debugging is a hugely beneficial thing because, like Amalith says, you don't have to remember how to use the debugger. It's not at all context dependent. I can use the same debugging techniques in my Python code and my Rust code and my C++ code instead of trying to figure out, actually, the best debugger for C++ is like Visual Studio, not VS Code, actual Visual Studio or whatever, and then remembering how to use it or whatever.
What's funny, though, is there are cases where you can do something like printf debugging and it can change the semantics of the code to where bugs no longer appear. So, for example, things around like locking standard out. Well, just by the act of taking a lock can change, if you're in some sort of like crazy multi-threaded context, can change the semantics of the program to where the bug no longer presents because now you've taken a lock and the system's had time to, to cycle. But that's like a really weird edge case.
And that's exactly the kind of bug where you might end up using printf debugging because you can't pause it in the debugger because it's to do with the interaction between multiple threads or something like that. So you end up dumping out a load of information just to try and figure out what's going on. And then it stops happening at all because of something like that. Or either just timing, right? Or because of locking on standard out or something like that.
Sometimes you can't find where to put the print statement because it doesn't actually hit that code path. And then that's always fun as well.
The number of times I've sat there thinking, how is this not printed? I put the print statement in.
Me, yesterday.
It sounds like the equivalent of watch tail log file then.
Yeah.
Yeah.
Pretty much.
It's an easy way to see what your app is doing in real time.
Right. And so a proper debugger then, in quotes, How does that differ? Like you're putting that into a separate program that reads it and analyzes it, or what?
Yeah, so there are several different types of debuggers. You can either have one that instruments the code live, where you can pause execution and you can then step through, so you can look at the particular, well, it depends on the language you're using. Like if you're using a lower level language, you can look at things like stack frames and see what, actual values are written into memory. You can watch different memory addresses and watch them change as the program runs. But all of this stuff that you have to do manually. You have to tell it to watch this particular address or look at this particular address in memory and print it out. And what print out means might just be a bunch of hex numbers. You have to tell it how to interpret that. But it's useful because you can tell the debugger to stop execution at particular points in the execution of the program and then look around at that particular, the stop point is called a breakpoint. You can have it look around at those different breakpoints. So that's super useful. There are other ones also where you can go backwards in time, whereas it's effectively kind of like a recording where you can step not only forwards through the code, but you can also step backwards. Like, how did I get here? Let me look at all the different stack frames below that and go backwards in time. And they're extremely useful, but because those are all different commands that you have to put in, they're archaic to say the least. It's like learning a whole other language to just try and find out what your program is doing.
We had in one of my CS courses probably the best exercise in working with a debugger that I've ever had. One of the few times that the university thing was great. I don't remember the name of the lab, but it was something related to bombs. You were given an executable, you execute it, and it immediately crashes, unless you provide a particular sequence of numbers to defuse the bomb. So you have to use a debugger to execute the program and make sure it stops before it would explode. You have to place that breakpoint before the point of exploding, crashing, whatever you want to say. And then you have to figure out what is making it explode. And using your debugger, you have to figure out which sequence of numbers prevents it from crashing.
Right, and presumably you couldn't do that with printf debugging because that's real time then.
Right, you don't have the source code. All you have is the resulting executable binary machine code. You have to use the machine code. I think they also gave us some of the source code so the debugger can look at the executable and show you the source code around that particular point in time. I'm not sure if I'm describing this well.
But you may not be able to change the source code even if you've got access to be able to look at it.
Right. And they omitted the particular part of the source code that would show us the answer.
Yeah, some debuggers will support disassembling the code as well and turning it back into source code. Usually that requires some additional information to either A, have been compiled into the program itself, such as debug symbols, or to have been provided alongside the binary. So a big difference between the debugging that we're talking about here versus printf debugging is the debugging we're talking about here, you don't need to change the source code at all. All you have is the binary and you're just running the binary roughly like normal. Whereas printf debugging requires inserting these print statements into the source code and then either recompiling or rerunning the program in order to see those new statements.
Yes.
I would say 99% of the benefit of a proper debugger is being able to step through the code and see what's happening and figure out what this variable is or why it goes into this if branch instead of that if branch. And I would say 90% of the work of using a debugger is figuring out how to run the debugger. Once you're in there, you've got step forward, step out, step in, and show me stuff. It's a bit annoying, but you can figure it out. But figuring out how to actually run the executable so the debugger can see the code, link up what code you're using and run your program. And it doesn't actually, quite often you'll run it in the debugger, but it immediately forks another process, which is not controlled by the debugger. And then, or something like that happens.
Yeah, debuggers are kind of magic where when it works and when you've invested some time into using them, they're amazing. And you're like, why don't I do this all the time? Until you have your very next problem and you're like, I'm just going to printf this real quickly.
Well, it sounds like it's not either or then. It sounds like why not just use both methods?
Definitely.
Yeah.
Definitely.
I think the shorter feedback loop with printf debugging can be very, very valuable. But other times, printf is just not enough and you need the ability of a debugger that can just look at everything. Because with printf, you have to sort of plan it out ahead of time this is the variable I want to print out and look at. While in a debugger, you can just look at the state of your program at this point in time, everything that is available.
And you can attach a debugger usually to a running process as well, which can be interesting. And some of those like recording debuggers, like RR is one, you maybe not customers, but if you have, say, a production machine running somewhere, you can actually have someone run the thing, let it crash, and then they just send you the debug report effectively. And then you can step through that execution forwards and backwards in time, even though you're not even live running the program anymore. But you can see, potentially where that crash came from.
That is awesome. I will say, though, sometimes using the debugger can be like a huge time sink. If you've got a mysterious bug, you can spend hours even persuading your code to get to somewhere near where you think the bug is in the debugger. So you can sink a whole load of time into that. So I hate to be like the one who bangs on about tests all the time, but if you've got a unit test that shows your bug and that unit test doesn't execute a great deal of code, then combining that with a debugger can be really, really powerful, right? Because now suddenly you're in a constrained environment. You know that it's quite easy to get to the code that you're trying to figure out, because you've got a little test around it.
That's one of the things that I've loved about Rust unit tests and integration tests is because it builds a binary for the test. It's super simple to have this one very constrained, very well scoped test, and then just run that tiny little thing in a debugger.
Absolutely. It's hugely powerful that like sometimes, the debugger is because you're lost and you need to deal with the complexity, but often if you've got a decent test, it can get you right focused on what you need, and then the debugger can be really powerful.
Or you can just put the printf statements into your test.
Yeah, that too.
Right, well, we better get out of here then. We'll be back in a couple of weeks, but until then, I've been Joe.
I've been Amalith.
I've been Kevin.
And I've been Andy.
See you later.